is Techstrong TV.
I'm Bonnie Schneider for Techstrong TV, and I'm joined today by Alex Rappaport, the award-winning CEO and co-founder of Zwitter, an innovative wastewater reprocessing startup. With a background in sustainability, Alex is on a mission to tackle the global water crisis by revolutionizing the treatment and reuse of the world's toughest industrial and agricultural wastewaters. Alex, that sounds like quite an endeavor. Thanks so much for joining us today on Techstrong.
Absolutely. Bonnie, great to be here. Thank you for having me on the show.
Well, I'd love to hear about your background and how you chose this area to really dive into for Zwitter.
Sure. If I rewind the clock, I actually started out as a river raft guide. So I used to teach whitewater stand-up paddleboarding, kayaking, rafting on the Potomac River just outside of DC. So as I was first trying to figure out where my professional career was going to go, those memories and those moments spending so much time outdoors was why I ended up pursuing environmental engineering. It's why I wanted to see technology deployed to helping sustainable challenges. And when I was in college at Tufts, I had the great fortune of getting connected with the research that had developed the initial technology that Zwitter has been founded on. And we've been building the commercialization story ever since. And in the last 5 years have been an opportunity to see these products really come to life in the hands of our customers, treating all sorts of wastewater streams that the world had previously said weren't filterable and wouldn't be eligible for reuse in the way that we're now seeing our customers able to better manage their water.
How big of a problem is wastewater? It's not something that, we think about every day, but it's all around us.
So something like 1/6 of the world's freshwater drawdown ends up as industrial or agricultural wastewater, hundreds of billions of gallons a day of water that is used for cooling, for cleaning, to create the processes that we end up with manufactured goods and services. It is hard to see it, but oftentimes the things that make our food take up 5 to 10 times more water than the food product itself. The way that our fuel comes around ends up producing immense volumes of industrial wastewater. And so often water has been a commodity that has not been too expensive or sort of too challenging to discharge of out of sight, out of mind. But as we see water scarcity, we see rising costs, and we see companies and groups that are really working to better manage their water footprint and achieve sustainability goals, there's been a big shift in the thinking about the investments required to better enhance treatment infrastructure and to start making those adaptations to being able to manage sort of as much of the water as you need on site at these facilities rather than constantly competing for limited or dwindling public supply resources.
One of the factors also I'm thinking about I have a background in meteorology, and we're seeing with climate change more sustained droughts that are happening longer, more frequently, longer lasting. And of course, climate change in general just happening at a faster rate than maybe most people realize. So how do these prolonged droughts affect your mission and what you're doing, and maybe add more urgency to the work you're doing?
Absolutely. I mean, we've seen everything from the 40% reduction in water available for irrigation and agriculture in the California Central Valley. We've heard about all of the impending water cutbacks that are likely to happen around the Colorado River Basin. So no longer are these day zero events or challenging sort of questions. How are we going to allocate water for public health and for urban usage as well as for industry and agriculture? These are no longer faraway problems. We're experiencing this every day. So the way that Zwitter tries to help address these issues is we're providing tools that give the companies that need to have their own access to hundreds of thousands or millions of gallons a day of water to run their operations. We want to give them tools so they can reuse as much of that on site and basically take them off the water grid or as far off the water grid as possible, so that as we see compression of available resources, I, as a meat and poultry facility, a dairy plant, a beverage bottling facility, I know that I have an independent, resilient supply of my own water. And no matter how the geography or the climate patterns shift, I at least have my future secured. We're seeing everything from companies that had built their facilities in locations where 30 years ago, there was no discussion about water stress, but they've watched their cost for utilities go up 8% year over year for the last couple decades. And now the cost of doing business is much more strenuous. We've seen other companies where they just can't access enough water. they've been drilling groundwater wells and they are maxing out what they have available capacity for. And as they've tried to drill more wells, access to more municipal water, the water's just not there. So as you start getting into, well, what do I do if I can't access my water? The challenges become very acute very quickly. You're hauling water in at exorbitant costs, or you're just limiting the amount of growth and production that you can provide. So it is something that people are really paying an acute level of attention to, as we've seen even the last couple of years, dramatic shifts in water availability.
That's a good point. And I want to kind of hone into this technology. It has a unique name that you're doing. How does it work, and what is unique about it? It's a membrane technology. Can you explain that?
Yeah, it is a membrane. So our membrane is made from a sort of a breakthrough material, Zwitter ionic copolymers, which is where we get our company's namesake from. And what this material is, when you think of a filter, imagine a coffee filter, semi-permeable barrier that is removing some contaminants out of a fluid stream and letting other things pass through based on the size of the pores. Most filters, most membranes are really good at removing salts or other species out of water. We see membranes used a lot in seawater desalination and municipal water treatment, but they really struggle to take out organic contaminants, things like fats, oils, proteins that often show up as byproducts in industrial manufacturing processes. So because filters are so quickly clogged, if you've got fat or oil in your water, you're going to really struggle to get an economic use of that kind of technology. What our chemistry, our material is effectively a non-stick filter. You can take oil and grease loading that is representative of a lot of industrial fluids, and you can clean the membrane easily. Simple water rinse will fully regenerate its performance, and you can continue using that same filter cycle after cycle for years in environments that would have otherwise ruined a standard filter in hours or days. And this all comes from effectively this chemistry. The Zwitter ionic copolymers are so hydrophilic. They really love to attract and hold on to water molecules that when they are filtering a slurry of challenging contaminants, they never have those contaminants stick to the surface or get stuck inside the pores, because they just love to hold on to those water molecules and stay hydrated, stay clean from that adsorption of tough to treat contaminants. So when we rinse them off, you're basically removing or dislodging any surface aggregated material, and you're uncovering a virgin membrane underneath.
Well explained, Alex. I would never have understood that. And I like the coffee filter analogy that kind of sets us up in your mind when you're visualizing it. But what are the developmental challenges that you face? This is a very innovative technology. I'm sure it wasn't smooth sailing all along the way. Can you describe some of the challenges that you faced and how you found solutions for them?
Sure. When you're really in those early stages and you have evidence at lab performance of a technology that has breakthrough performance, that doesn't mean necessarily that it was designed to be manufactured at commercial scale. And thinking about the difference between hand-created prototypes versus material where you're making it by the mile, which is the volume that you need to actually treat meaningful volumes of wastewater. What we needed to figure out early on was either how are we going to find all of the money, the funding to invest in the equipment and facilities to have full manufacturing ourselves, which is a pretty tough proposition when you're asking investors and high-risk capital providers to say, we need multiple millions to build a thing that hasn't ever existed before. Or you're looking to potentially partner with larger companies where you don't necessarily have the same incentive structures. We existentially need to make our products in order to see the business grow, but larger manufacturing companies just don't have that same agenda necessarily. And it's difficult for a small company to get into those kinds of mature relationships. So one of the things that we were able to do that is unique to our industry is that we were able to silo or segment each of the different things that needed to be manufactured: the polymers, the membrane, the assembled elements, and how we do quality control. And we designed very specifically the way that we synthesize and the way that we produce our materials so that it could adapt to contract manufacturing, that we could have outsourced partners that were sort of on a toll or on a fee-for-service basis able to do each of the stages of production, so that we weren't investing in our own equipment, but we weren't signing up for a partnership we weren't prepared for. And those unlocking some of those development hurdles meant that we went from lab scale prototypes to doing all commercial testing on industrially relevant manufacturing methods in the span of only a couple months after the company was founded. And that was a big opportunity for us to demonstrate the sort of scalability of the product, even as we were in our sort of high risk, what is this technology and how does it work stage when speaking with investors.
That's interesting. Our audience on Techstrong TV, a lot of them are working in the IT industry, in software. Can you kind of dive into the technology that was needed, that you leaned into when you were developing this company, in terms of the technical support that you were able to acquire through your team?
Sure. So I was very lucky when I first founded the company that I got connected to my two co-founders. One of them had been in industry for about a decade, working at various advanced materials and membrane companies. Another was a field engineer who had been servicing water and wastewater treatment in all sorts of tough industrial applications. And so the two of them, Chris Drover and Chris Roy, helped bring for us a very early lens of how you think about that R&D, prototyping, scale up, design for manufacturing, sort of breadth of skill sets, and that we also had a way to think about what's the value proposition of this technology? How do we design equipment or test profiles that allow us to work with customers and partners on those early evidence or trial bases? And so very quickly on, we had a broader skill set in the founding team that knew how to both attack some of those commercial scale up and manufacturing scale up challenges. Is that sort of the direction that you were looking to head there?
Yeah, I think it's really interesting, because I think that a lot of the titles of the people that helped you there are watching, people are in similar roles. So it's interesting to see how that can come into play, especially for a company that has a sustainable mission. And that's sort of where I wanted to kind of wrap it up today, of what this means to you. And you mentioned your background, you'd done rafting, and so you had some personal experience on the water. But now that you're well into Zwitter Co. and you're seeing the impact that it's having, what is the connection to the sustainable movement that triggers that's most important to you?
Absolutely. We have a broad moonshot at the company, which is to recover half of the world's industrial and agricultural wastewater. If it's in a centralized facility, if it comes out of a pipe, we want to be there with the fleet of tools needed to treat and make eligible for reuse those wastewaters. And to me, what that moonshot means is this almost near impossible mission, where if we're headed in that direction, we know that we're trying to have the impact to make the good use of the technology that we have to support these sustainable ideals. And that future, what that vision would look like, is a world where water is not the constraint to all of this sort of public health, decarbonization, resource recovery challenges that we see showing up in so many industries, right? If we can help industry have their own reliable, resilient source of water, then we don't have to have that competition over private and public supply. If we can see the industries that are supporting renewable natural gas, green chemicals, plant-based proteins, not have water be the thing that holds them back from their growth, then these other industries that are tackling climate change and decarbonization in their own right have the most efficient way to scale those businesses up. And then as the final point, there's so much that we have in our wastewater that has value. And when we dump it down the drain, it ends up being a contaminant or an environmental pollutant we have to deal with. But if we can extract those materials in a way where we recover their value, you create new product streams, new revenue streams that help industries look at, I have a waste, now it's a fertilizer. I have a waste, now it's a feedstock. And that helps that transition to advanced treatment, because now you're looking at new drivers to the bottom line. And that trifecta, to me, of the resilience, the sustainability in other industries, and the resource recovery all speaks to how water is just this underpinning resource underneath all of these different industries.
Thank you so much for linking all of those together in a way. I don't think that most people put that into perspective, how water really connects all of the areas of sustainability and making the most of our resources. And I really appreciate your time today. Alex Rappaport, award-winning CEO and co-founder of Zwitter Co., an innovative wastewater reprocessing startup. Thank you so much, and we wish you the best of luck as you continue to grow.
Thank you, Bonnie. It's great to be here.
All right, thanks. Stay with us on Techstrong TV. We'll be right back.